Have you ever wondered why bridges don't collapse when you drive over them? The answer is simple. Civil Engineering by Hanna and Ava.
So what does a civil engineer do? Civil engineers work to maintain and build structures such as bridges, dams, and buildings in the physical and natural worlds. There are many specific and different subdisciplines to a civil engineer's job. Civil engineers work in the public sector with the government, as well as in the private sector with major private companies. The history of civil engineering. The earliest practice of civil engineering was recorded between 4000 and 2000 BC in ancient Egypt, the Indus Valley, and Mesopotamian civilizations. There is no distinction between civil engineering and architecture until the modern era, which is around the 18th century. The Great Pyramids, circa 2700 to 2500 BC, and Quinault water system, circa 1000 BC to 1 BC, are some of the first major constructions of this field. Qualifications. Civil engineers typically have an academic degree in civil engineering. They study for 3 to 5 years and complete a Bachelor of Engineering or a Bachelor of Science in Engineering degree. They then become professionally certified through experiences with working with companies and managing projects. They take classes in physics, mathematics, including calculus, algebra and geometry, and project management. After basic courses, they move into more specific disciplines, including earthquake engineering, environmental engineering, and forensic engineering.
A problem that many civil engineers might encounter during their work is a problem of the moment of inertia, which is used for maintaining an object's state of rotation or rest and is used in construction. And it is the measure of the amount of moment given to the body to overcome its own inertia. So in the equation, there's r, which is the distance between the axis and the rotation, m, which is the mass of the object, and L, which is the length of the rod. And the distance is always going to be in meters, and the mass is always going to be in kilograms. So these are different examples of moment of inertia equations, and they differ based on the shape of the object that is being calculated. But they follow the same basic pattern, which is mr squared times a constant. And a very simplified example of a moment of inertia problem is the mass of a sphere, which is 5 kilograms, and the radius of a sphere, which is 3 centimeters. And to find the moment of inertia of the sphere, first you have to change the units of the radius because it's in centimeters. So that would become 0.03 meters. And then to calculate the moment of inertia, you multiply the mass times the radius squared. So it'd be 5 kilograms times 0.03 meters squared, which equals 0.0045 kilograms times meters squared.
So the moment of inertia of the sphere would be 0.0045 kilograms per meter squared.